Here we have a problem. It's the ideal gas law, and it's a little bit wordy as they usually are. So we got iodine. It has this formula I2. Remember, it's diatomic. So it's a solid at room temperature, but sublimes, that means it converts into a gas when warmed. So we have a gas, all right? What is the temperature? So we want to know what is the temperature, all right, in a 73.3 milliliter bulb, all right? So the bulb, that means volume, is 73.3 ml, okay? ml has units of volume. mmHg, that's millimeters of mercury, that's pressure, that's something else, okay? So this is just the volume, and it contains 0.292 grams of iodine, okay? So the mass is 0.292 grams, okay? And I'm going to write the chemical formula after this. And it has a pressure of 0.462 atmospheres. Now, we don't have two pressures, two temperatures, or two volumes, so we're not going to use one of those other gas law problems that you may have learned. We're going to use the ideal gas law, okay? To use the ideal gas law, let me just jump ahead a step, and then we'll go back to do what we should do at the beginning. This is probably what students will do. So they'll see that, okay, we need the temperature, right? Here it is. So we need to divide both sides by PV, all right? I'm sorry. We need to decide both sides by NR, okay? And the R cancels, and the N, which is moles, cancels, okay? And we're left with a new formula. T is equal to pressure times volume divided by moles times the ideal gas law, okay? And now you can't just plug in things because, okay, we have the volume. So the first thing that we need to realize is that R is given to us. And we need each of these quantities, and these are the units, okay? So first of all, as we go down the list, we don't know temperature, all right? We know volume, but it's in milliliters. We need it in liters because R is in units of liters. So we need to divide that by 1,000. We'll just do that in our head. That's 0.0733 capital L. Okay, so you're just moving that decimal place over 3 to the left. All right. A mass is 0.292 grams. Mass is not in this formula, but N is. So what is N? We can find N from the grams. Okay, from the grams. So we have 0.292 grams of iodine, okay? And we need to convert that to moles. Now, the thing to realize here is if you look on your periodic table for the capital I, which is element number 53, it has a mass of 126.90. But there's a 2 here, which means we need to multiply the number on our periodic table by 2 because it's a diatomic element. So when we do that, we get 253.8, okay, grams of iodine. That's equal to 1 mole of iodine, okay? So we're going to use this information right here in this box to fill in this conversion factor. So we know that 1 mole of iodine weighs 253.8 grams of iodine, okay? And the grams here are going to cancel out. And this is going to give me the needed moles of iodine, and moles is given to us in the units of the ideal gas law constant. So 0.292 divide 253.8, that's going to give me, my calculator expresses it as scientific notation, but that's going to give me 1.15 times 10 to the minus 3. And the units here are moles, and the chemical is iodine, okay? Now we have the moles of iodine, okay? So we have liters, we have moles. Pressure we need in atmospheres. Hey, that's already in atmosphere, so that's great. So we've got everything set up here kind of before we do surgery here and just plug everything in, okay? So temperature is PV over NR, so let's plug and chug. P is 0.462 atmospheres. The volume, we're going to use this number here in liters. Okay. The moles, we've calculated it. I'll make it yellow here so you can see where this number came from. But the moles is there, okay, that we calculated using the numbers off our periodic table. And I'll just write MOL here, okay. And then the R constant is up here. It has all these units. It's hard to fit in there, so I'll just put mole Kelvin under the fraction like so. Okay. And for the sake of, completion here, let's very carefully make sure our units cancel. So atmospheres is correct. Okay, capital L is here and here. Okay. And moles cancels, okay? And I'm going to be left with 1 over Kelvin, right? Which is just Kelvin, all right? So let's grab our calculator and punch these numbers in. Okay, be very careful when you do this. And so again, we're solving for temperature. That's 359 Kelvin. Okay, I'm going to do this a second time just to make sure I'm not making a data entry on my calculator. And I urge you also to double check. I don't want you to lose points on your homework or something because of my mistake. So 359 Kelvin. All right, so that's the final answer there. So that's how you do this problem. There's a lot of work to get things into the correct units. Thanks for watching, and please consider subscribing to my channel. Have a great day.